and welcome to the first episode of Learning from Home with Mrs. Beckett. Today we're going to take a look at multiplying and dividing binomials. So it's important to remember the difference between using exponent laws with algebraic expressions and collecting like terms for algebraic expressions. So when do we use the two? Well, we use exponent laws when we're multiplying or dividing terms, which is what we're going to be doing today. We collect like terms when we add or subtract terms, which is what we did before the holidays. So remember that there are different types of polynomials. We can have a monomial, which has one term, a binomial with two terms, a trinomial with three terms, and a polynomial, which means any number of terms. We'll start with collecting like terms. So when we add or subtract terms, remember that we can only add or subtract terms that have the same letter with the same exponent. So that's important to note. So if I have 5x cubed plus 4x cubed, because these are both an x cubed, then I can add these terms together. So 5x cubed plus 4x cubed gives us 9x cubed. So we add the coefficient in front of the terms. If I'm taking a look at 8x to the exponent 5 minus 2x squared, these are not like terms. Even though they both have an x, they have different exponents, so I can't simplify this any further. So this one can't be simplified any further, so there's no like terms to simplify, so this would be the final answer. When we're taking a look at exponent laws, and we're looking at the exponents of something. And I'll just get rid of this randomness on the screen. We don't have to worry about having like terms. So that's the beauty about multiplying and dividing binomials. We just have to make sure that we're looking at the coefficients. So that's the number in front of our variable, and we're looking at our powers. So when we're multiplying using exponent laws or dividing terms using exponent laws, we first think about what are the coefficients. So 5 times 4. Well, 5 times 4 is 20. And now I'm going to look at my powers. So both they have the same base, so that's important to note. So I'm still going to have an x. And remember that when I multiply exponents and the bases are the same, then I add, or multiply powers and the bases are the same, then I add the exponent. So I add 3 plus 3, which will give us 6. When I'm looking at dividing monomials, again, I want to look at my coefficients. So 8 divided by 2 is 4. And then I look at my powers. My bases are the same. When the bases are the same and I'm dividing the powers, I subtract the exponents. So 5 take away 2 is 3. So that's just a quick refresher on those exponent laws that we looked at before the holidays. If you have any questions about these, please let me know if you need some more practice using exponent laws. So now let's take a look at some questions involving multiplying and dividing binomials. So we'll start with multiplying binomials first. So when we're multiplying binomials, we need to think about, again, the coefficient. So the coefficient is the number in front of the variable. So we first multiply the coefficients. So 3 times 4 is 12. And then we use our exponent laws to think about our powers. Remember that when we have no exponent associated with a letter, then it's an imaginary 1 that's there. So my bases are the same, so I'm going to have my A, but I look to see what my exponents are, so 2 and 1, and because I'm multiplying the powers together, I add my exponents. So it's 2 plus 1, so that becomes 12, A to the exponent 3. Let's take a look at the second example. Also be aware of our laws for multiplying and dividing positive and negative integers. So a negative times a positive integer gives us a negative answer. So we start with our coefficients. Negative 2 times 5 is negative 10. And because we only have one power, we can just write our n squared at the end. And there's nothing more that we need to do with that power, that variable term. Moving on to some ones that are maybe a little bit more trickier. I have 3d times negative 5d. So remember that the brackets mean multiplication. Multiply your coefficients together. So 3 times negative 5 is negative 15. So if you are struggling with your multiplication tables, remember that you can always either practice those or you can use a calculator if that's a tool that works for you. Add those exponent of 1 if that's helpful for you, for those variables that don't have an exponent with them. Our bases are the same, so I can write my d, and because my bases are the same and I'm multiplying the powers, I add my exponents. 1 plus 1 is 2. And then this would be that final answer. Next example. Multiply your coefficients first. Negative 3 times negative 6 gives me positive 18. So remember, two negatives multiplied together give you a positive term. Look at your exponents. My bases are the same, so I have a z, and I'm going to add my exponents because I'm multiplying. 2 plus 6 gives me 8. And that one's done. Remember that we can only apply our exponent laws to variables that are the same, so keep that in mind as well. So if I wanted to add another term to this one, 4t times negative t, maybe I want to also add a 2s to here as well. I want to multiply my coefficients first. Remember, if there is no number in front of a variable, again, it's that imaginary 1. So I'm multiplying 4 times negative 1, which is negative 4. And negative 4 times 2 would give me negative 8. So that's just multiplying your coefficients. 4 times negative 1 times 2. And then I look at my exponents. I can only apply my exponent laws to the exponents that have the same base. So I have two t's, so I can make that imaginary exponent 1 right here again to help me out. When I'm looking at my t's, I can't combine my t's with my s's at this point. So when I'm looking at my exponent laws, I can only use my exponent laws for the common bases. So I can only use my exponent laws with my t's. So 1 plus 1 gives me 2. And then I have that s at the end. So I can't combine the exponents for the t and the s because they are different variables. So this would be the answer for this question right here. So remember that we can only apply the exponent laws when the powers and the bases are the same. All right, let's take a look at this last example. So again, look at your exponents. Look at your coefficients in front of those variables as well. So 2 times 1, remember that's an imaginary 1 is 2. And 2 times negative 4 gives me negative 8. And then look at your powers. All three of these, have a base of x. And I'm going to apply my little 1 up here for everyone. So I'm going to add my exponents together. 1 plus 1 plus 1 is 3. If you have any questions about multiplying monomials, please let me know. Feel free to rewatch these videos, pause them, rewind them, whatever you need to do to make this learning more efficient or successful for you at home. And when you feeling like you are ready to tackle some questions on your own, I'll get you to take a look at the Check Your Understanding questions, which are posted on Brightspace. So take a look at Part A. There are lots of questions within Part A, Part B, and Part C. I've highlighted a few questions that I want you to focus on. If you are struggling, please make sure that you try more than what I've assigned to you so you have that practice so that you are answering the questions until you get them right and so that you feel more confident with them before you move on. For Part A, do question number 1, just Part B, F, and J. 3, A, B, and G. For Part B, do number 6, 7, A, H. 8, B, D, K. And for Part C, do question 11, which deals with scientific notation. So we'll see if we can apply what we know about multiplying monomials to the scientific notation that we looked at earlier. The answers are available to you on Brightspace, so in that document. So make sure you're checking the answers on Brightspace. Work productively at home. I know there are lots of distractions, but try to stay focused on the math that you're working on. Ask for help if needed. If you have a parent or guardian at home who can help you, that's great. If you have an older sibling, that's awesome as well. If not, feel free to send me an email. There is also Mathify available. Remember, that's that online tutoring. If I can't get to your question right away, you might want to take advantage of that. So lots of tools available for you and resources available for you if you need that extra assistance. So feel free to send me an email if you have any questions or use the resources around you, whether those are virtual resources or in-person resources as well. So pause this video, try these questions, and then restart it when you're ready to move on to dividing monomials. So now let's take a look at dividing monomials. So just like we did with multiplying monomials, we want to look at the coefficients first. So I have 35 and I'm going to divide it by 7. So 35 divided by 7 gives me 5. I know that from my multiplication tables or my multiplication facts. If you are struggling with doing these in your head, don't be embarrassed to use your calculator. Use the tools available for you to be successful. And then I just have an X, so I'm going to keep my X right there. So this was a relatively easier one out of the ones that we're going to take a look at. So again, look at the coefficients. So 35 divided by 7 is 5, and then look at your variables. So I just have an X, so I'm just going to put my X there. Taking a look at the second example, 48a divided by 6a. So I'm going to look at my coefficients first. 48 divided by 6 is 8. Now I'm going to look at my variables. Remember, if there is no exponent, there's an imaginary 1 on your variables. So my bases are the same, so that means I can apply my exponent laws. When I divide powers, I need to subtract my exponents. 1 take away 1 is 0. Now it's important to remember what happens when we have an exponent of 0. Anything to the power of 0 or anything to the exponent of 0 is 1. So this becomes 8 times 1, or 8. So keep that in mind as you are doing your questions today. If you need to go back and look at your exponent book of exponents that we made earlier this school year, feel free to take that out as you are doing these questions today as well. Next set of examples. So I'm going to take a look at my coefficients. 15 divided by 3 is 5. Now I look at my variables. My bases are the same. They are both a c. So that means I can use my exponent laws. Remember, if there is no exponent, there's an imaginary exponent of 1. Because I am dividing my powers, I subtract my exponents. 2 take away 1 is 1. So it's going to be 5c to the exponent of 1, or also remember that I don't have to write that exponent of 1. I could just write 5c. Remember that division can be written as a fraction as well. So we don't always have to use that division symbol. We can express it as a fraction. Sometimes writing it as a fraction makes it easier for us, especially when we have more than one variable. So again, we're going to start with our coefficients. We're going to start with our numbers. 21 divided by 7 is 3. Now we're going to look at our powers, and we can only use our exponent laws when our bases are the same. So we're going to simplify our x's first. So 3 take away 2 is 1. Then we look at our y's. Here's my imaginary exponent of 1. 4 take away 1 is 3. And then I look at my z's. Here's my imaginary ones that I'm writing in. 1 take away 1 is 0. And remember, anything to the power of 0 is 1. So I'd be multiplying 3xy cubed times 1, which would just be 3xy cubed. So when you have an exponent of 0, it just means that this variable ends up disappearing. So it's no longer there. So when we think about this, we can also think about they cancel each other out, right? So if we had 5 divided by 5, that gives us 1. And so z divided by z also gives me 1. So it's a whole fraction. Okay, so think about that as well if you want to. All right, let's take a look at a couple more examples. Sometimes your fractions, your coefficients aren't going to work out nicely so that they make a whole number at the end. And that's okay, so don't be afraid of those. So let's take a look at these ones. So 16 divided by 6. Well, 6 doesn't divide evenly into 16. So I'm going to put this into lowest terms. So we've done this before when we looked at fractions. So I'm looking for a number that will divide evenly into 16 and 6. Well, I know that these are both even numbers, so I can divide these by 2. So 16 divided by 2 is 8, and 6 divided by 2 is 3. And I can't make that any smaller. There's nothing I can divide 8 and 3 by that is going to give me a whole number. So 8 over 3 is 16 over 6 in lowest terms. So now I need to look at my exponents or my powers. I first look at my variables that involve the m. Because I'm dividing, I'm subtracting my exponents. 4 take away 3 is 1. I can choose to write my exponent of 1, or I can just write it as m, whichever makes most sense to you. Then I'm looking at my n's. 2 take away 2 is 0. Now remember, we can simplify this further because we have an exponent of 0, which means that this turns into 1. And because this is 1, then we know that really we're just going to be left with 8m over 3. Because this is 1, anything multiplied by 1 is just itself. All right, let's take a look at one final example. 12 over 36. So these are my coefficients. I'm going to look at that first. Okay, so I can either think about these are both even numbers, so I can divide them by 2, or if I am confident with my factors and my divisions or my multiplication tables, I know that both of these numbers are divisible by 12. So 12 divided by 12 is 1, and 36 divided by 12 is 3. If you need to take additional steps to get to that, you can. If you divide by 2 and then divide by 2 and then divide by 2, feel free to keep doing that if that's a strategy that works for you. Or you could do it into lowest terms in one step. So both of these are divisible by 12. So 12 divided by 36, 12 divided by 12 is 1, and 36 divided by 12 is 3. So this 12 over 36 reduces or becomes lowest terms to 1 over 3. Then I'm going to take a look at my variables. So starting with my D. Here's my imaginary exponent of 1. 5 take away 1 is 4. And then I move on to my E. 3 take away 2 is 1. Then I move on to my F. 4 take away 2 is 2. So if I want to, I can rewrite this so that instead of having a 1 at the top now, because this 1 is being multiplied by everything in the numerator of my fraction, I could just write this as D to the exponent 4, E, because I don't need to write that 1 if I don't want to, and then F squared over 3. If you would keep your answer as the second step, I would mark this correct for now, but know that you can simplify this or write this a little bit neater in this last step here. All right, now it's time for you to try some of these on your own. So go back to that check your understanding page. So again, you're going to work productively. So I know it's easy, you have lots of distractions at home, but try to stay focused on the math that you need to do. Ask for help if you need it. So email me questions if you need to. Ask a parent or guardian or an older sibling if you have that available to you. Or you can go on and look at some online resources like TBO Mathify. So use that if you need to as well. Check your answers on Brightspace to know that you're doing these questions correctly. And again, there are lots of questions, but I'm only going to highlight a few for you to focus on. If you need the extra practice, do more questions. So from part A, do question 2, AEK, 4, ACF. From part B, do question 5, DH, 7, CF, and 9 CE, and part C, take a look at question 13, okay? So pause this video, practice some of these questions, and then resume the video when you're ready to try the next challenge. All right, so now that we've spent some time looking at multiplying and dividing monomials, let's see if you can apply this to an open middle task. So we do some of these types of questions in class as a group. However, you are at home and you might not be able to work with groups. So we're going to take a look at trying to do this on your own. And then we'll go from there. So here are the instructions. So use the whole numbers 1 to 10. So no negative numbers, no decimal numbers, no fractions. So you're entering either a whole number like 1, 2, 4, and so on in each of these boxes. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have to use every single number from 1 to 10. And you want to fill in the boxes to make this statement true, okay? So you can only use one number one time, and you have to make the left side of the equation equal the right side of the equation. So this is a challenge, so see if you can do this. If you think you have the correct answer, then what I want you to do is I want you to scan your answer in as a PDF So if you're working on this on a piece of paper, there's a video that I'm going to upload to show you how you can scan using 2 free apps on a smartphone if you don't have a scanner at home, using the OneDrive app and the Pulse app, which are 2 free apps that work on both iPhones and Android phones. So keep that in mind. So try this. Answer this question, send me your results as a PDF. I want to make sure that you know how to scan something as a PDF while you're at home, and then I'll give you some feedback on that task. So pause this video, try some of these questions, or try this question. Figure out how to send this to me, email this to me as a PDF is your final answer, and then when you're ready, restart the video for the next task. All right, so the last thing that you're going to be doing is just 3 quick questions to show me that you know what you need to do for multiplying and dividing monomials. So this counts as your quiz mark. So your multiplying and dividing monomials mission, you should be able to see that now in Knowledge Hook. So 3 quick questions. Remember, you can do this as many times as you need to in order for you to achieve a satisfactory mark. So try that out. Again, if you have any questions, let me know. And remember that you love math. So thank you for watching this first episode of Learning from Home with Mrs. Beckett, and I will see you at the next episode.